Hello, everybody. Today I'll be going over how to do binomial probabilities in a TI-84. Now, a binomial probability is a probability that has a set number of trials that are independent and have only two possible outcomes, which we usually label as successes and failures. Once I have identified that my question is a binomial probability, I can then figure out three important numbers to plug into my calculator. These numbers include my number of trials, n, my probability of success, p, and my number of successes, x. Because the binomial distribution is a discrete probability distribution, whether or not I include x in my probability will change how I substitute my numbers into my calculator. That also means that I am going to have 5 possible outcomes that I might substitute into my calculator. These include equals, less than or equal to, less than, greater than, and greater than or equal to. If I am calculating equals, then I can do the binomial PDF function. But if I am calculating anything with an inequality, then I need to use the binomial CDF function in my calculator. Both the binomial PDF and CDF function can be found in the distribution section of my calculator. To get to that, I'll press second and then bars. Then I can scroll down until I find binomial PDF A or binomial CDF B. Both the binomial PDF and CDF function in the TI-84 will ask me for my number of trials, my probability of success, and my number of successes in that order. Once I have substituted those numbers into my calculator, I can press paste in order to see a preview of what that probability should look like. I can use this preview as a way to double check if I have substituted my numbers in correctly based off of the equal sign or the inequality sign that I have chosen for my question. For the binomial PDF function, my probability preview should look like binomial PDF parentheses n, comma, p, comma, x. For less than or equal to, it should say binomial CDF parentheses n, comma, p, comma, x. For less than, it should say binomial CDF parentheses n, comma, p, comma, x minus 1, because I am not including x in the probability that I am calculating. Both greater than and greater than or equal to require that I use the complement of my probability. So I can do 1 minus that probability before I do the distribution. So for greater than, I will type 1 minus binomial CDF parentheses n, comma, p, comma, x. And then for the greater than or equal to, I will do 1 minus binomial CDF parentheses n, comma, p, comma, x minus 1. I can use each of these previews as a way to double check to make sure that I have substituted my numbers in correctly into my calculator. Now, I will do some example questions to see what this would look like in a real problem. In my question, it says, suppose that Carlos is taking a multiple choice test with 15 questions where there are 5 answer choices and he randomly guesses on them. Before I calculate the probability, I have to determine if this is a binomial distribution. First, I have to check, do I have a set number of trials? Yes, I do. Here I have 15 questions in my 15-question test. They are not changing. Do I have independent trials? Yes, each question on my multiple choice test is independent of the other one. If I answer the first question right, that does not change whether or not my second question is going to be right. And last, do I have only two possible outcomes? Yes, I'm either going to get the question right or I'm going to get the question wrong. There are 5 answer choices, but if I am just guessing on those questions, my options are get it right and get it wrong. So because all 3 of my conditions are true, this is a binomial distribution. Now I can identify my N, my P, and my X for each of my probabilities. For part A, it asks, what is the probability that he gets exactly 3 of the questions correct? For my question, I know that I have a set number of trials, N of 15, which I identified in the last step. My P in this case is going to be based off of the questions themselves. So for this question, it says that there are 5 answer choices. That means that my probability of success of guessing correctly for one of my questions is going to be 1 out of 5. And for part A, because it says exactly 3 of the questions, my probability that I am interested in is the probability that X equals 3. I can write this in my probability notation by saying P parentheses X equals 3 close parentheses. What this says is I am finding the probability that X equals 3, just in shorter words. Because this is X equals 3, I know that I am calculating the binomial PDF of this calculation. So I can go ahead and click second bars and then go down to binomial PDF. My number of trials is 15. My probability of success is 1 out of 5. And I can put this as either a fraction or a decimal. And my X in this case is just 3. Once I have typed in my numbers, I can check my preview, and you'll see that my preview says binomial PDF N, comma P, comma X, which matches what my preview should be for the equals sign. So my probability that he gets exactly 3 is 0.2501. For part B, it asks me what is the probability that he gets at most 6. At most is the same as less than or equal to. So in my probability notation, I can say P parentheses less than or equal to 6, which means that I want to use my second option for my preview when I substitute all my numbers in. So in my calculator, I'll do second bars, binomial CDF. My trials are still 15. My probability of success is still 1 out of 5. But here, my X value is 6. And I am including 6 in my probability, so I am not going to have to subtract 1. I can double check my probability. I can see that it says binomial CDF. It has n, comma, p, comma, x. Therefore, my probability that he gets at most 6 is going to be 0.9819. For the next question, it says that he gets fewer than 5, which means that I will use my less than option for my preview. This one says that I need to do x minus 1. So I will still click second and vars, and then go down to binomial CDF. My trials are 15. My probability is 1 out of 5. But now my x value, I'm going to type 5 minus 1 because they give me an x of 5, but we are not including that number. So I will subtract 1 from it. I can double check my preview to see that my less than says binomial CDF, 15, comma, 1/5, comma, 5 minus 1. I personally like to put the x minus 1 inside of the x value, but you can also just subtract it. I could have put 4 here if I wanted. My probability that he gets fewer than 5 correct is 0.8358. For the next question, it says more than 4, which means that I'm going to have to use my fourth option. Here, I have to do the complement because it is greater than. So before I plug it into my calculator using the distribution, I am going to just simply put 1 minus and then do the distribution. So I'll say second bars and then the binomial CDF. My trials is 15. My P is 1 out of 5. And my X value in this case is going to be 4 because it says 4. I can double check my preview. It says binomial CDF n, comma, p, comma, x. And I still have my 1 minus at the beginning. So my probability that he gets more than 4 is going to be 0.1642. Now, if I forget to do the 1 minus beforehand, I can technically subtract it from 1 at the end. I just have to remember at some point for anything that is greater than or equal to, I have to do the complement. And last but not least, my final question says, what is the probability he gets at least a majority of the questions correct? This one is harder than the other ones because it doesn't give me what x is. I have to find what x is before I can do my probability calculation. A majority is going to be more than half of whatever my number of outcomes is. In this case, my number of outcomes is 15 because I have a 15 question test. So a majority or more than half of 15 is going to be 8. So the way I can rephrase this to help me calculate it properly is I am trying to find at least 8 of the questions. Just like how at most is less than or equal to, at least is greater than or equal to. So my probability that I am calculating is the probability that x is greater than or equal to 8, which means I will be using my last preview as my means of plugging numbers into my calculator. In this case, I will do my 1 minus first because I am doing a greater than value. Then I will do second bars, binomial CDF. My number of trials is 15. My probability is 1 out of 5. And then my x in this case is going to be 8 minus 1. Just like before, I can double check to make sure that my entire probability matches the preview that I'm supposed to have. I have my 1 minus binomial CDF n comma p comma x minus 1. Then I can press enter and I can see that the probability that he gets at least a majority is 0.0042. And that's how you calculate a binomial probability using a TI-84. Okay.